All right, so what we're gonna do is last time we talked about limits. Do you guys understand this or no? Yes? Yes? Somewhat? Did I show you the decimal thing or no? I show you the decimal how the h is slowly decreasing, went from a secant line to eventually become a tangent line. Did I show you that? Well, this is what happened, right? So it start with secant line, start with those 2 points, and start with the black point and the blue point. That's a secant. And the h slowly decrease, so my slope is constantly changing until it get to that specific point. So h is going to reduce down from so this is the h, right? Basically, you start from here, right? Then the h is going to go down. See that h is decreasing? Smaller and smaller and smaller and smaller and smaller. And each time I'm draw a line, and that's going to be secant line until this point, then I'm going to get a tangent. So that means you can get a tangent at all points. So when limits h approach 0, that becomes a slope at that point. Now, you're going to say, okay, what does that look like in terms of decimals? So we're going to show you. And if you're interested, you can always get a computer out, and you can actually pull this out. And they have inherited those things on the side. So you guys can take a computer, more welcome, because you need to learn how to use decimals. So get your computer out if you want. On the side, on the side, there is a calculus right here. Do you see the calculus? And it says secant line. Do you see that? So you're going to click that on it. And that just say, I want to find the slope on the point on the left. Okay. I want to find the slope, tangent line slope on the left. So do you see that h value here? The third line says h equal to 2. So what I'm going to do is I'm going to slowly decrease. Eventually becomes tangent. See that 0.0? It's undefined. Do you see that slope? It says undefined. But we can get so close to it, and we can say, oh, how about 0.01? How about 0.01? How about 0.001? You see that slope is reached like 1.045. That is almost the slope. But we can safely assume that's a good value because even I put in extra 0, it's still 1.045. So we can say the slope of tangent line is 1.045 at that particular point. Not only that, you can actually do the slope, and you can just say, hey, what if a slope at all points? I can figure out a slope at all points. All I gotta do is click the slider for A. You see the A is 0.73. I can slide them, and I can see slope at any moment. I just have to stop. Do you see that slope is constantly changing? Kind of like a roller coaster. That's like the momentum you feel on the roller coaster because that's a straight line compared to the roller coaster. Does that make sense? Mm-hmm. Look who's here. Yeah. Deborah's not here and you're not here. This class is like dead.
I know. I'm so sorry.
Yeah, you should be. You got a late pass?
I know. They made me get a late pass. Trust me, most of the time I just sneak right past. But I didn't go through the front today because I was like so late.
Come here, go around here, knock on the door. I'll open it.
Oh, yes. Okay. So what are you doing today?
I know, because you and Deborah are not here. Okay, so where's Deborah?
I don't know.
Okay, so now, so we're going to talk about there was 4 perspectives in calculus. The first perspective, so perspective in calculus. Perspective. How to spell perspective? Perspective, there are 4 perspectives. One is look at things algebraically. Don't quote me on spelling, I can't spell anything. The next thing is graphically. Third thing is numerically. The fourth thing is analytical. So there are 4 perspectives in math. 50% of the problem usually can be done with algebraically. 50%. Graphically, it's probably 30%. It's a good portion. If you don't understand it graphically, that's going to be a big part. I would say numerically is probably like, 5% of the time. And analytically, it's going to be 15% of the time. Not everybody can think things analytically. Not everybody. Only some. Those people who can score a 5 usually can think analytically. Those people can only do algebraically, can probably get a 3. People can think graphically, probably it's going to get you 4. Now, if you can think analytically, then that's going to give you a 5. That's pretty much overall sums up. So, unless you're wanting to outwork other places. So we're going to say first thing, find limit algebraically, right? Find limits algebraically. We're going to talk about graphically later. And the first thing is always, you want to find limit, just plug in a number. If you plug in a number that just says when limits x approach to 3 of x plus 2, x approaching 2, 3, so it'd be 3 plus 2, that's equal to 5. And that's it, you're done. You're gonna be, man, I wish this test right here, because I can, but this test will be easier than pre-algebra if a test just like this. So unfortunately, you're not gonna have too many questions like this. Even you're lucky, you might get 1. Second things, you're not gonna get 0. You're not gonna get a number. You get a situation called 0 over 0. This is what we're gonna spend bulk of our time between Monday and Tuesday, is 0 over 0. Some of you guys know something over 0 is undefined, right? Let's say a number over 0 is undefined. But 0 over 0, we never did talk about it. 0 over 0, there was a name for that. It's called indeterminate form. This is T. That was really bad. Indeterminate. How do you spell indeterminate? Man, my handwriting's really ugly. Indeterminate form. Indeterminate form. An ATE, right? Okay, indeterminate form. In calculus, there's 6 indeterminate form, but most of them are BC. They're not in AB. AB is 0 over 0 and infinity over infinity. But if I have 0 over 0, that means this indeterminate form. When you ever reach indeterminate form, you're going to do all kind of math that you can think of. All the math is on the first test. Okay? you actually did most of the math on the first test and or in a packet. So the first part of math is called a cancel factor. Cancel? Oh, factor and cancel, sorry. Factor and cancel. The second part of math is every time you see a radical, it has something to do with conjugate. C. If you guys see a complex fractions, you're going to do a combined fractions, which is also on the test. So that's why it's so important that you actually know what you're doing on the first test, because it's going to relate to this test. D. Every time you see an absolute value, you're going to do something called piecewise function. And do one-side limits. Okay, so there are 4 situations can occur if you have 0 over 0. Actually, those other situations can occur. Now, this is just a big picture. So then for the next 3 days, we're going to keep on coming back to this picture. The last one, we're not going to get to it. For the next couple days, it's going to be number over 0. Number over 0 is going to require you to do something called one-side limit. Okay, one-side limit is going to be resolved with 3 situations. Infinity, negative infinity, and does not exist. So basically, if you want to find limit algebraically, there's 3 situations can happen. One, if you plug in a number and you get a number, you're done. The second situation, which is the bulk of the test, is going to be 0 over 0. If you have 0 over 0, it's indeterminate form. If it's indeterminate form, there's all kind of math that you can think of. So that means factor can cancel, radicals. You have to do something called conjugate. And complex fraction, you have to think of combined fractions. And D is going to be absolute value. You gotta be like, whoa, yes. Let's talk about factor and cancel. Let's just say when limits x approaches to 2 at x squared minus 4 over x minus 2. What's the first thing when we do limits? What do we do first? You have to analyze which case it belongs to, right? Not yet. What are you supposed to? Before that, you're not sure it's that case. You had to do what? No. Just plug in. Yeah. If you plug in, you will get 4 minus 4 over 2 minus 2, right? 0 over 0. Please plug in, because sometimes some question just simple as just plug in. You end up screwing up because you didn't plug in. So 0 over 0 is indeterminate, so therefore you limit x approach 2, then you can factor it, right? So that's going to be x plus 2 and x minus 2 over x minus 2. And x minus 2 will go ahead and simplify it down. And that's equal to x plus 2. But there's a limit in the front. Don't forget about that. Now you can plug in, so it'll be 2 plus 2. That's equal to 4. That's pretty easy, right? All right. Now let's talk about a hard part. Remember, there's 4 different perspectives. The first perspective is algebraically. What's the next perspective? Look at graphically. So let's look at a graph. Does anybody know what a graph of x squared minus 4 over x minus 2 look like? No? Kind of like parabola. Nathan, what do you think? X squared minus 4 over x minus 2. Natalie, how'd you do on your SAT?
Math are good, I think.
No. How about reading?
Well, I didn't go so well. I didn't do much next reading, so.
I'm going to help you one other question today. Okay, what's the graph of x squared minus 4 over x minus 2 graph look like? Nobody can tell me. Huh? You look it up? That's smart. Okay. If you don't know, look it up. You suppose know this though, however, but x squared minus 4 over x minus 2. But this is not any straight line. This is an abnormal straight line. You cannot tell it's deceiving. It's a straight line, but it's not. What can you tell me there's a problem here? I'm going to show you though. Let me click on one of the lines, right? And let me scroll around and see if you see anything abnormal happen.
Oh, is that weird undefined at the fourth?
Oh, look,
Yeah. There's a hole.
there's a hole. So it's not any straight line. And this hole is called a removable discontinuity. We're going to talk about that. Remember we talked about a black hole last time? A small, tiny black hole? This is that situation. So we cannot know the GPS of that, so we're going to approach it slowly, right? So obviously you see that 2 is undefined if I plug in a table. And if I plug in, that says 1, and I press enter, I'll plug in 1.5, and I'll do 1.9, and 1.99, and then 1.9999. Do you see that value eventually is going to what? 4, right? 1.99999. And the more 9 I go, what will happen? It will eventually go to 4 because the calculation can only do so far. So eventually they're going to say it's roughly 4, even though it's undefined at 4. So it's going to be an open hole. And you can approach both ends too. 2.0001. It's going to be 4.00001. So that's why we say we talk about both sides, enrich slowly until you get to the black hole. And this is a very, very tiny black hole. Okay. So this is the first part. Now, what situation happened here though? In Algebra 2 or pre-calc, you also learn something. If you have a cancel factor, it's going to result with a hole. If you have something cancel factor, you set that equal to 0, that's your hole. In calculus, we don't call it a hole. We have another name. So in calculus, we says that's a removable discontinuity. Okay, removable discontinuity. So anytime you have a cancel factor, there's a removable discontinuity. You take that cancel factor equal to 0. So let's just say x minus 2 equal to 0, even though you cancel it, x equal to 2. So 2 is where the removable discontinuity. The 4 is the coordinate. So 2 comma 4 is the removable discontinuity because if we find the limits, that's going to be the output. The output is going to be the hole. The x equal to 2, y value equal to 4, that's where the hole located at. Question about this part? You're doing good? Now let's go to the next part. And let's think. Huh. How about I just switch around a little bit? Okay. Let's just say, how about limits x approach to 2? X minus 2 over x squared minus 4. What do you guys think the graph look like? In this case, is I'm going to challenge you to look at a graph every single time because you got to see the graph. And Trent already plugged in because she's like, I don't know what a graph look like. Right, Trent? Good. At least I'm too lazy to take it to my computer. I'm just going to see what Trent type in. Okay, it turns out what happened here. What do you see here, Trent? Yeah, there's something called reciprocal graph. Yes, you're right. That's a good name, actually. Reciprocal graph. In a reciprocal graph, there was something very important happen. Something called non-remote discontinuity, and we're going to show you that. So let's do the limits first. Well, we plug in, this is 0 over 0. So then you say, okay, limit x approach to 2, and that's going to be x minus 2 over x plus 2 and x minus 2. And this will cancel out. And that's equal to 1 over x plus 2. Don't forget that 1. X approach 0, x approach 2, sorry. That's going to be 1 over 4. So limit is going to be 1 over 4 as opposed to 2, as opposed to 4. Because every time you cancel, you're going to write down 1. But the new equation has something else. It has something called vertical asymptote. Do you see the bottom? When bottom equal to 0, it's going to be undefined. When bottom equal to 0, it's going to be the undefined. So not only you have to know, how do you find removal discontinuity? You had to know how to find vertical asymptote. How to find vertical asymptote? How to find vertical asymptote? Is the denominator. After you cancel though, denominator equal to 0. That's going to be denominator. I just don't know how to spell things. So denominator equal to 0. So when denominator after cancel, I'm going to show you, I'm telling you it says after cancel. Not before you cancel. Before you cancel, it's going to create two things. So after you cancel the x minus 2 out, the x plus 2 equal to 0, that x equal to -2. So in this case, x equal to -2 is a vertical asymptote, and there is another name for it. This name is non-removable discontinuity. Okay, non-removable discontinuity at x equal to -2. Now, x minus 2 is still a removable discontinuity. So this is x equal to 2, y equal to 1/4. It's going to be the removable discontinuity. So it's going to be removable discontinuity. Why? Because that's a hole. Second one is not a hole. Second one's a vertical asymptote. A hole you can plug in. You imagine if you have a hole that's leaking in a water bottle. You can take a tape, just tape it. Or a bubble gum, you can chew it and just fill the hole and it will stop leaking. Hopefully. Right? So that's called removable discontinuity. I can fill in that hole, it's continuous. If if I don't fill in the hole, it's non-continuous. But vertical asymptote is no way for you to fill in because that's an infinite line. It's not, if you fill in the line even, it's not going to be continuous because that's filled as a function. So you cannot have a function if you're like that. Okay, so if you look at the graph, it's going to look like this. I'll show you what a vertical asymptote is. X equal to -2. That's going to be a vertical asymptote. That's a line that they never touch. It's not shown on the graph, but it's there. You think about it, they never touch. Do you see that? They never touch. Have you seen this in pre-calc? Vertical asymptote, right? But there's also a hole. Hole at where? At 2. Go look at a 2. It's almost close to 0.25. So before that, it's 0.25, right? 0.25 is 1 over 4. We know at 2, there's 1 over 4 as a whole. So there's a removed discontinuity and there's non-removed discontinuity. Does that make sense? Okay. Now let's go to, let's see if you guys know harder factoring. So sometimes I can give you a couple questions. I can say it's limit x approach to, I don't know, 3 of x cubed minus 27 over x minus 3. This is factor the cube. It's on your packet, but not on your test. Do you guys remember how to factor the cube? Nadi says, I know how to factor the cube. How do you factor x cubed minus 27? Yep.
Isn't it like a squared, b squared, or is it just ab, and then a squared, ab, b squared?
So I'm going to show you the slope. It's a cubed plus b cubed equal to a plus b times a squared minus ab plus b squared. So a cubed minus b cubed equal to a minus b, a squared plus ab plus b squared. The way to remember it is slope. This is going to be the same sign as before. This sign is going to be opposite. And the last one here is going to be always positive. So you see this is positive. You see here this is always positive. And this is always opposite signs. Opposite signs, right? And this is the same signs as before. So it's slope. You remember how to factor the cube? Are we okay here? How do you remember the back part? The back part just like how many different blood type if you have A and B. Remember Putnam square in biology? If you have AA as your mom and your dad is BB, then wait. No. Oh, sorry. If your mom and dad both have AB blood type, then you're gonna have 25% you get A, and 25% you get B, and 50% you got AB. Do you guys remember that? It's a Putnam square. Okay. Anybody take AP bio here? You taking it now? Are they talking about Putnam square? No.
I mean, yeah.
Yeah, but they talk about more detail though. They talk about a P and P size and second generation and third generation. Yeah. So at this case, how do I factor this? On the bottom is x minus 3, right? On the top is what? X minus 3, good.
It's x squared minus
Plus 3x AB, right? So it's x and 3 and plus 9. Those will cancel out. Limit x approaching 3, x squared plus 3x plus 9. That's equal to 9 plus 9 plus 9 is equal to 27. So even though I didn't test you on the first test because there's too much information, I can test you on limits if you know how to factor the cube. And that's how you factor the cube. Okay. Some of you guys need to know how to factor using a box. I know a lot of you guys are reluctant to factor with a box. I'm going to tell you, it's going to help you a lot. Matter of fact, there was one SAT question. I don't know. You were not here on Friday afternoon. Emil, remember? Emil got stuck in that question. And he had been scored 100 on all the tests. And we give him a SAT question he cannot do. It was just simple factoring. But he tried to factor with the cross method or diamond method and didn't work out. And I said, how about using the box? And he did it in like 30 seconds. He was stuck in a question for 15 minutes. He just looked at it. He's like, I don't know how to do this. So a box method help you. If you need to know the box method, please tell me. So he tried to do factor by grouping over there. And he was really good at it. But the problem is, I think Devon used factor by grouping as well, right? A box is going to be better, I'm telling you. I proved that Emil says box is better. And he didn't believe me. But at the end of the day, he sell. So all kind of factoring today you got to be deal with. But we're going to deal with second situation. So we finished the first situation is factor and cancel. We're going to deal with the second situation here. Radical. A lot of you guys don't know how to do radicals. Do you know what's conjugate mean? What does conjugate mean, Natalie? You're nodding your head. You don't know the definition, but what do you know what to do? No. Yesterday on Saturday on SAT, do you see any problem deal with I? No? Okay. Well, your next test might have now. So because this test doesn't have it, the next test probably will have it. So sometimes they ask you like this, 3i plus 2 over 2i minus 3, like this. 2i minus 4, let's do that. And they say, hey, can you find the a plus bi form, and can you find the b? What is a plus bi? A plus bi in pre-calc is a complex number, and it's just going to be in a plus bi form. But the problem, this one's not in a plus bi form. How do you get there? You need to rationalize this. Does anybody know how to rationalize this? Yes, man. Why is 2i plus 4? Okay, so 2i plus 4 here. And what do I do at the top? Same thing. Why? Because 2i plus 4 over 2i plus 4 is 1. So if you multiply that, you're not changing it. You just rationalize this. So good. This is on your SAT. And then you can multiply the bottom out. What the bottom is going to end up equal to? Remember, if you have a plus b times a minus b, the result is always a squared minus b squared. The nice thing is a squared minus b squared can get rid of I, because you got I squared is going to be -1. Do you remember this? Yes? No? Maybe? So on the bottom, it's going to be 2i squared minus 16, right? Does that make sense? On the top, it's going to be 6i squared plus 12i plus 4i plus 8. Any questions so far? On the bottom, it's going to be 4i squared minus 16. And this is going to be 6i squared plus 6i plus 8 What is I squared is equal to? -1 plus 6i plus 8 over -1 times 4 minus 16. So that's equal to -20 on the bottom. On the top, it's going to give you what? 2 plus 6i, right? Now, they say a plus bi form. That means you had to split. Remember, when bottom is monomial, you split them. And that's going to give you -1 over 10 minus 3 over 10i. And 3i over 10. And if they want to ask for b, then it's going to be -3 over 10. If they ask for a, it's going to be -1 over 10. Depends on what question they ask you. So that way you know this is the type of math that you had to deal with. And this is on SIT. Are we okay here? You've done this before in Algebra 2. I don't know if you did it in pre-cal or not. I don't think so, right? In pre-cal, you did it with the polar, supposedly. Now, what I want you to do is, I want you to do this question. What happens if you plug in? X over square root of x plus 1 minus 1. What happens if you plug in? Not x over 0. It's 0 over 0. Right? So if you have 0 over 0, what do? Math. What kind of math you can think of? I say when you have a radical, usually deal with the conjugate. What is conjugate of this? Or hey, what's conjugate of this? Yes, it's opposite sign, right? What happened on the bottom? That's the most important part. What happened at the bottom? It's going to be a minus b times a plus b is going to be what? A squared, right? Minus b squared. What is the a squared in this case? Just x plus 1, right? Super easy. What's the b squared? Minus 1, right? That's it. I'm done. What the hell is he doing? Okay, what happened to the top? So, but don't distribute in. The key thing is don't distribute in. The key thing is to cancel out the x. Why? Because I can write down like this. If I can write down like this, I can write down as like this. You don't want to distribute in. Because you distribute in actually make it worse. That's going to be limits as x approaches 0 of x over x times square root of x plus 1 plus 1. So it becomes something that you can cancel. Do you see that? If you cancel, what happened? It's going to be 0 plus 1 plus 1. So it'll be square root of 1 plus 1. So it's equal to 2. So the whole goal is cancel that x on the bottom. Jesus. Does that make sense or no? How much time we have? 3 minutes? Okay, I'll give you questions. With the conjugate, it's a little bit harder. Let me give you a questions here. Let me see. Okay, let's deal with this. Now, you're gonna be like, I never had to rationalize numerator. Yes, you can rationalize numerator. You can rationalize the denominator as well. So not all the time you have to rationalize denominator. Rationalize the denominator is a lie. We lied to you because the answer is going to be uniform. What happens if you plug in 0 here? No, you get indeterminate. Yeah, not undefined. Because you're going to get 0 over 0. Because you get square root of 2 minus square root of 2 over 0. So 0 over 0. So can you? Okay, here's the result. Plus 2 and minus 2 cancel. The x cancel. Don't distribute the x. If you distribute x, it's going to give 0 over 0, number over 0, which is actually worse. The x cancel out, then you got 3 over square root 2 plus square root 2. Bye, have a good day.
Oh, I'm sorry, you told me to keep this, but do you not want me to have it?
Huh?
You told me to keep it, but do you not want me to have it? 'Cause-
Yeah, you're not supposed to take it. I did tell you to take it?
Yeah, you said
Oh.
you could keep it.
Oh, okay.
I didn't show anyone.
That's fine.
Yeah.
Bye, have a good day. Don't mess up the group in front.
Thank you.
You're not a group leader. Yeah, yeah. No, you're not. Oh, I nominate that as my fellow group leader.
Who?
Mr.
No.
No, Zach would be better. Daddy? What? Yeah.
Skill was Zach is better.
Zach would be way better. Wait, no. Zach should be the only person here. That should be the only person.
How about that just the band kid? Huh? Yeah, exactly. Oh, you guys excluding Baz on page?
It's not excluding, it's just
I see Darby every day. I saw it.
What?
You like that? You like that? You all see? You like you all see?
All like the review.
We didn't have to deal with it. She was arguing.
It was not. Wait, what? What are we?
No.
No, I got it. Not sharing equal bodies. Just act like
We're in BC.
Yeah.
team leader. No.
I see.
First off, is the team leader seat? Oh, I better not see you. Sheila, you're gonna have to be. You have to be Oh. Hey, no, Molly. Oh, that's it.
All right. Shh. All right. Shh. Huh. Thank you. All right. I want to make sure you know all the derivative and even applications. So I'm gonna just kind of like a summary of all the derivative. And now I'm gonna give you questions that you guys can do. I supposed to give you the weekend, but no, I'm too lazy. I'll give you a test. All right. Shh. Okay, so first application goes, do you know how to find several things? So let's just say, start with find vertical tangent. We talked about vertical tangent already. What is a vertical tangent? Slope equal to 0?
That's horizontal. This is why you're not. This is okay. That's horizontal. Vertical. That's vertical.
Okay. Okay, how do I find, raise your hand if you think you know vertical tangent. Yes, Will. Shh.
It's when it's when the derivative, so the slope approaches infinity.
Which is, how do I find it algebraically? I just say if I give you an implicit situation, if I got like the answer is yes.
I think it's like after you take the derivative, you look at the denominator and find the 0.
Yes. Okay, so the dy dx, right? The denominator of dyx, denominator of dy dx is equal to 0. Not the numerator. Numerator equal to 0 is what?
Horizontal.
Yes. Horizontal tangent is numerator of dy dx equal to 0. So please know in those two things. Now review. How do I find the vertical asymptote? Denominator of original function equal to 0. And how to find the horizontal asymptote? Not necessarily highest power. Okay, let's review. That's on your last test that you take on Friday. Vertical asymptote is denominator equal to 0. Denominator of f of x equal to 0. And the horizontal asymptote is limits x approach infinite of f of x equal to L, or limits x approach to infinite of f of x, or negative infinity of x equal to 0. Okay, so those are the things that you need to be able to master those skills. You have to know the difference between vertical tangent and vertical asymptote. Tangent usually occur at a derivative because tangent is the slope of tangent line. So that's only happen on derivative. Okay, so those are things that you need. If I ever ask you horizontal tangent, numerator equal to 0, denominator equal to 0. I can give you implicit derivative. So you guys got to figure out. Questions? We ended last week with the chain rule. Okay. But do you remember how to do chain rule of the trig? Okay, so do you remember how to take a derivative of that's a tangent to the third and cosine to the square over square root x? Do you know how to take a derivative of this? Are you sure? So let's do it.
Yes.
Katie, be nice. Be nice.
Why?
Because your dad's nice. Wait, what's Katie's dad like?
Very
Don't you remember last year in 7th period?
Ethan's dad was the family.
Yeah, it's like he's like in love with Katie's dad. He asked for his phone number.
What?
He likes to
He's like, can I have your dad's phone number?
He likes to talk a lot. He was off on
He's dad.
Oh, shit. I tried to throw at a sword wheel. I tried to curve that thing. I was like trying to throw it like this and then curve. Because that's a Hispanic thing, they can throw a sando and they can curve. Yeah.
First, I'd like to take out of
There is no product rule. Okay. Raise your hand if you think you know the answers.
Yeah.
Oh, Jake. Hey, I cannot talk over you guys. Jake, yes?
3 tangent squared cosine squared.
3, hold on, tangent square of cosine square root x.
Yeah. Times secant squared of cosine squared of square root x times 2 cosine square root x.
Hold on. 2 cosine. So 2 cosine square root x. Good. Okay.
Times negative sine of square root x times 1/2 x to the negative 1/2.
That's actually perfect. You probably trying to do product rule.
Remember that cosine square is also square.
Everybody on the side of the see.
I know, I got it.
Okay, so shh. All right, so this part is good. So then you should know how to do things generically. You should know how to take a derivative that says if I have f of g of x and to the square, you should know how to take a derivative of this generically. So this is offering exactly the same thing. If I take a derivative of this, it's going to be what? Theta dx is going to be 2 f of g of x times g prime of x. So this one's all okay, right? Okay. We can go and move on. I'm going to give you a very ugly function. You're going to have to tell me how to take derivative of this. This how do I take a derivative of this? It's not chain rule. It's not quotient rule either. It's not. Your life is going to be miserable. No use substitution. Shh. Guys, don't talk. Raise your hand if you think you know it. Page. All those people got a 5 can take a derivative of this.
No.
Yeah.
Yeah, Zach, what do you say?
Split it up like x squared, 3x plus 2 squared times root over 3x plus 2 squared. Like that.
How do you do that?
Quotient rule for that.
No.
Because the fractions.
If you know it, raise your hand. Yes, Samuel?
You make like u equal to x squared and stuff.
No.
Bruh.
But you said substitution.
I never did say substitution. You on crack, I didn't say. Oh my god, all those people get a 5. Let's go back, change to a 4. Yes.
Would it be you natural log both sides?
Oh.
What?
Yeah. All right, so shh. Let's think about how to take a derivative of this. Yes, you can use natural log both sides. So what happened is this is nothing to do with chain rule and quotient rule because it's going to be a very messy situation. You're going to have to find a way to break this all up. If you break this all up, it's going to be, well, it's not taking derivative yet. I'm just going to do natural log of y equal to natural log of, and this is everybody last year always screwed up this question. I don't know why. So you natural log for both sides. You're not taking derivative. You're not taking derivative. You're gonna break to small parts, and you're gonna say natural log of y equal to natural log of x squared, which is also known as 2 natural log of x, plus 1/2 natural log of 2x minus 1, minus 4 natural log of 3x plus 2 to the 4, like this. And then now you're gonna take a derivative of this. So it's gonna be y prime. You're gross. I think that's what Katie's gonna say.
I agree, thank you.
Yeah. Okay, so now I take a derivative. Now derivative of natural log of y is y prime over y. And that's gonna be 2 over x because plus 1/2 2 over 2x minus 1 minus 4 times 3 over 3x plus 2. And then 2 cancel out. And then don't forget about this y. This y is still there. So it's going to be y prime 2 over x plus 1 over 2x minus 1 minus 12 over 3x plus 2 to the whole function, which is x squared square root 2x minus 1 over 3x plus 2 to the 4th power. You guys remember this? Jordan, thank you. You're the only person to deserve a 5. The rest of you guys go downgrade to a 4. Shh. And this is on last year, everybody failed. I remember a lot of you guys did this with the chain rule and it was really gross. Okay? So how do I take a derivative of
That's it?
Okay, how do I take a derivative of something to the something power?
Say that one more time.
Cosecant of x to the 10 of x. Yes. There you go. No, anytime you have a function to the function, the only way is to take a derivative of the exponent, that's it's a function, it's an x, always lead to natural log differentiation. Always lead to log. It's anything to the x power. If x to the any constant is always powerful. But if something like a to the x, right, a number to the x, right? So sometimes I can ask you this. Sometimes I can ask you, says y equal to 4 to the x. That's also same thing. So I want you to take a derivative of those two things. Y equal to 4 to x and y equal to cosecant of x to 10 to x. Now.
But you know, oh no, that's possible.
I can see the angle.
Yeah.
I still got it.
All right, so the first one's harder, so I'm gonna guide through it. The first one is, like Will says, okay, the key thing is anything to the variable power, always something to do with natural log. Why? Because you have to somehow bring the power down in order to take a derivative. So first of all, I'm not taking derivative. I'm doing natural log of y. And that's gonna be natural log of cosecant of x times 10 of x. And then that's going to be natural log of y is equal to 10 of x times natural log of cosecant of x, because the power it can bring down. Now I'm going to take a derivative of both sides. D to the dx on both sides, so it's going to be y prime over y. What's the derivative of 10? Secant square of x. Natural log of cosecant of x plus what? Well, 10 of x times derivative of u prime over u. Negative cosecant of x, cotan of x over cosecant of x. Would you say? Is that okay so far? What else? Can I cancel out this? Can I cancel out tangent and cotangent? Because cotangent is 1 over 10, right? So that's equal to secant square of x times the natural log of cosecant of x plus 1, or minus 1, sorry. And y prime over y. So it's going to be y prime equal to secant square of x, natural log of cosecant of x. Samuel. Minus 1 times by the cosecant of x and tan of x. So that's natural log derivative, natural log differentiations. You had to be able to take a derivative natural log differentiation. This is on VC Calc. More, it's actually on Calc 2 in college. Any questions here? How do I take a derivative of 4 to the x? ln both sides, good, but this one's kind of tricky because that's going to be ln of 4 to the x, ln y equal to x ln 4. So it's y prime over y. What's the derivative of ln 4? Just ln 4, right? So it'll be y prime equal to ln 4 times 4 to the x.
See, I thought you would put y, or, algebra, oh my gosh.
Okay, so Sarah Zhang and Ginger had a similar questions. Says, do you do product rule here? If with the product rule, it's gonna be the same thing. But think about it. ln4 is a number. It's no different than 4x. What's derivative of 4x? Just 4. So this case, derivative of x ln 4, that's just gonna be ln 4. That's it. So there's no product rule, but if you do a product rule, it's going to get a result the same thing, but the other side is going to be 0. But this is just a constant multiple rule. Question about this? So natural log derivative is also part of the game. Okay, can I move on or no? Today we only talk about all the natural log. And also I'm going to talk about e to the x. How do I take a derivative of e to the square of x cosine of x? How do I take a derivative of e to the 2x minus e to the x minus e to the negative x over e to the negative x?
Is that e to the negative exponential at the bottom?
So it's the derivative.
Okay, so you don't do ln on both sides, no.
It's like correcting the path.
Bristol, you okay?
Bristol is time to find
What?
Bristol is not.
Okay, for first one, just a product rule. And a chain rule. Because there's a combination other power than 1, it's going to be a chain rule. So it'll be 1/2 x to the negative 1. Oh, that's actually, yeah, chain rule and the power rule, right? So the first one is derivatives done. Sometimes you don't take a derivative. You're going to say, hey, that's do e to the 2x over e to the negative x minus e to the x over e to the negative x minus e to the negative x over e to the negative x. E to the 3x minus e to the 2x minus 1, right? Now let's take a derivative. So dy dx 3e to the 3x minus 2e to the 2x minus 0. Which is you don't have to write it.
X, right? You know that. So you don't have to use that law. Something like 4 to the x calculation.
What time we get off here? Huh? All right. Shh. The next thing we want to talk about is inverse derivative. Do you guys remember how to do inverse derivative? I don't remember the questions. I forgot my textbook, so. All right. Shh. Do you guys remember how to find inverse derivatives? That's always on the exam. So we're gonna talk about inverse derivative. Let me see if I can find the questions. Yeah, inverse derivative. Yeah, it's always on AP exam. It's probably on last year's AP exam too. It's pretty easy. Here's the last question. Hold on, I cannot find it. All right, so this will be the inverse function. So it'll be x to the fifth plus x, and the inverse function f inverse of x is equal to g of x. And they say, can you find g prime of 2?
What? You can't find the inverse function. Wait, is it f right here? Is it f?
I understand.
Yes. And then take a derivative of
Okay, so let me write an equation on the top.
Oh wait,
I think it's 1/6.
yeah, I think
One six. The answer is 1/6. Okay, so this is the one question that they overlap on A, B, and B, C. So please know how to do this question. It's on my test, it's on BC test, and it's on AB test. So it's one of the tests that they have overlap. This is one of the questions that you have to be able to do. Okay, what is the derivative of this function? What's the derivative of g inverse of x? It's 1 over f prime of a g of x, right? Or f 1 over f prime f inverse of x. Yeah, you can do the chart. So what happened is this one, if we in terms of charts that I told you guys will help you. So g of x, this is the x, right? This is a y, right? So that means this is 2. This is a question mark. And this is 2. This is f of x, right? So 2 is equal to f of x, which is a y value, of x fifth plus x. Now in this case, you cannot, there's no way for you to solve except just randomly check. Well, you can check either 0, 1, or -1, or 2, or -2, but only one makes sense. So x has to be equal to 1, so therefore this one has to equal to 1. So what you're going to do is take a derivative of this. So what's derivative of this? Derivative is going to be 5x to the 4th plus 1. And you're going to plug in 1. So it's going to be 5 times 1 to the 4th plus 1. So it's 1/6. That worked. Very good. Inverse derivative is one of those things that's always on it. So just I don't know why. People usually forget. It's always on competition as well. So those of you guys that are going to competition this year, it's always on competition questions. Always. It's the one question that they always test, doesn't matter which test. Okay. So we talk about inverse, we talk about logarithm, we talk about e to the x, we talk about exponential function. The one last thing I want to talk about is what? We talk about trig, we talk about inverse, we haven't talked about a combination of both, right? Inverse trig. Huh? We haven't got the integral yet. All right, so I'm gonna write down two equations to help you, but the one that is most happen most than the other one is d to the dx of a sine inverse of u is equal to u prime over square root of 1 minus u squared. The next one, the most popular one, is gonna be this. On BC Calc, it's gonna happen on tangent. In tangent, you're gonna learn how to complete the square when you take in derivatives. So complete the square is also on your SAT. Those of you guys take SAT should have complete the square questions on that. Or no? Jinju, no? Not this one? Not the Saturday one? They say they have it. It's a circle or parabola?
You didn't need to complete the square though. It was already completed. It was already completed for us. It was distance formula. They're not giving how they gave you the end point and the center.
Oh, okay. All right. So u prime over 1 plus u squared. This one, that's something that you need to know how to do for sine and tangent. There's one other one I usually don't remember either, but it's a secant. So d to the dx of secant inverse of u is equal to u prime. Now this one usually never on the test, so I usually don't remember it. Question about this. So let's just say, can you take a derivative of sine inverse of 2x? Do you know how to take a derivative of that? Just follow the formula. So it's equal to what? 2 square root of 1 minus 4x squared. That's it. Okay, so you know how to take an inverse derivative, inverse trig, e to the x, exponential function, and all that. Okay, what else? Inverse trig, inverse, let me see. Did you no? Shh. Okay. What?
I said, okay, right, 2 plus 2 is 5 minutes, right?
No, wait, more is peace.
I'm gonna say your parents decide.
More is peace.
Your
More
parents.
is peace.
I'm gonna take points off of it back to your parents.
No. More. There we go.
Right? We're taking points off and we'll see the parents.
What?
I actually want to see Katie's dad. I want to see the legendary Mr. Coleman. Her dad teacher English. Everybody knows her dad. Dad's like one of the most popular teachers. I was like, yeah, I'll tell you that. I can tell it's hot. I don't feel it.
We started on you can find it on the left of my desk. And then we're gonna do these here. You're welcome. Thinking we also do the blood.
Yeah, we can with that.
But like a lot of new kids show up today. Like for the first, like they've been on my roster for 2 weeks, but like today they showed up.
Yeah, I have that in the app. And they say school don't allow them to come in. They just school doesn't allow them to come until like it's the system. Let's say the system. It's this kind of work. I have one student that she missed 2 weeks in calculus. I'm like, I call the parents. The parents said school doesn't allow us to come in. I'm like, you're my
registration thing.
I don't know, but it's this guy work.
Students, 1 minute remaining until class.